So, hello everyone. My name is Ohad Regev. I'm an MD PhD student here in Ben-Gurion University, and I'm doing my research on identifying specific biomarkers of abnormal development among children with autism during prenatal life using fetal ultrasound. So ASD is a neurodevelopment disorder characterized by impaired social communication and repetitive restrictive behaviors. And nowadays, this behavior is usually diagnosed at the age 3 or 4 years old when the core symptoms of the disorder are noticeable. Nevertheless, recent studies show that some kind of early signs or biomarkers may be seen even before these core symptoms are found. One of these early signs is abnormal development of the head. Recent studies show that children with autism are born with either smaller or a normal-sized head, followed by an overgrowth of both the head and the brain. And this overgrowth was mostly seen in the frontal lobes, as well as abnormal CSF, extraaxial CSF volumes above the frontal lobes, which give to their heads some kind of an elongated shape. Also, several studies conducted on children shortly after birth show that blood drawn from these children had a smaller amounts of growth hormones which are in charge of the neurodevelopment prenatally, as well as a post-mortem study conducted by Casanova, which showed that children with autism have very small and very concentrated neurons in very specific parts of the brain as compared to controls, once again suggesting that an abnormal neurodevelopment during prenatal life. So all these findings suggest that the abnormal overgrowth we see from birth onwards to early childhood is some kind of a reaction or adaptation to something that's going on during prenatal life. In addition to abnormal head and brain growth, studies found that children with autism have higher rates of comorbidities and congenital birth defects, with studies by Dawson et al. Showing children with autism have higher rates of congenital malformations, as well as multi-organ malformation. Another study conducted here in Beersheba showed that children with autism have higher rates of visits to clinics due to anomalies or sickness in the heart, kidneys, GI system, and more. And a recent study conducted by Sigmund et al. Showed that children with autism have higher rates of congenital heart defects, mostly ventricular septal defects and arterial septal defects. In addition, a recent study published last year showed that specific genes previously associated with autism also affect the development of different organs in autistic fetuses during prenatal life. And specific genetic syndromes and genetic mutations have been shown to be associated both with autism and malformations in different organ systems, including the kidneys, heart, GI systems, and many more. For example, I bring here these two children with a mutation in CHD8 mutation. The children with this mutation have been shown to have an overgrowth from birth during early life, an overgrowth of their head, wider set eyes, anomalies in their heart, while children with anomalies in Phelan-McDermid syndrome show a longitudinal and smaller head shape and anomalies in their kidneys. And so all these findings suggest that some kind of abnormal growth is may be happening during prenatal life. And a great tool to examine exactly what's going on with these fetuses is fetal ultrasound, which is most commonly used around the globe to investigate fetal growth, organ development, and many more. The fetal ultrasound allows us investigation of different parts of the brain of the fetus, fetal head, and other organs. And there's different ultrasound screening conducted throughout pregnancy from the first trimester till birth. Several previous studies tried to investigate this topic with several case reports, small case reports on children with specific genetic syndromes, showing and later developing autism, showed that these children actually had some organ anomalies, including a dilation of the renal pelvis or a ventricular-occipital defects in their hearts. Other studies used biometric measures, which measure the head width or head circumference during prenatal life, and showed and had some contradictory results. Some studies show that children with autism have smaller heads, while other studies show that children have actually larger or wider heads. Though these studies had lots of drawbacks, they had very, very small sample size. They didn't account for potential confounders such as familiar or sex bias, which is known to be males with autism are much more common than females and also affect biometric measures. And they looked at different gestational periods. And so it was not very sure exactly what's going on during prenatal life. And so we decided to use fetal ultrasound in order to investigate fetal development. We conducted 2 studies, one on biometric measures conducted during 2nd and 3rd trimester, and the other study investigated fetal anatomical development during the 2nd trimester. I'm going to talk about both today. Our data was based on 2 large data sets. The first one is from Calais Health Services, which have extensive ultrasonographic data on 90% of the children born in southern Israel, as well as the database of the National Autism Center, which have clinical, genetic, and sociodemographic data on hundreds of children here in southern Israel. Our first study focused on the biometric measures taken from 14 weeks of gestation till birth. This ultrasound scan has basic biometric measures measuring the head circumference, head width or BPD, the abdominal circumference, I hope you can see the mouse, and the femur length. Our study included 174 children with autism, matched to 2 control groups. The first group was their closest in age typically developed sibling, and the other controls were same matched by sex, ethnicity, and age from the general population. So, investigation of the clinical and sociodemographic background between ASD cases and the 2 controls showed no significant differences except for a difference in the sex between ASD children, which had a ratio of about 1 to 4, as is known to happen in ASD, compared to a proportionally 1 to 1 proportion between a TDS group, between their sibling, between males and females. The results of our study showed that children with autism had a significantly smaller and narrower head, or it can also be called dolichocephalic, as can be seen here, compared to control groups. Both ASD sibling cases and their typically developed siblings had this abnormal head during 2nd trimester. We investigated this divided by male and females. Males can be seen in blue and females in red, and we can see there's actually a difference between males to females in the biometric measures across all groups. And so we looked at each gender separately, and so males had the narrower and elongated head shapes, while ASD females had a smaller and proportionally sized head. Interestingly, while both ASD and their sibling had a smaller head during 2nd life, throughout pregnancy their sibling managed to close the gap and were born with normal sized head, while children with autism were left behind and were born, just as seen by previous studies, with a smaller head compared to controls. Our elongated head shape we saw is also in line with previous studies which show this abnormal growth mainly in the frontal lobes of the brain and in extraaxial CSF volumes, which may explain our findings. Finally, the study showed a sex-specific correlation between the abnormal head growth and ASD severity. This study was published a few months ago in the Journal of the American Academy of Child and Adolescent Psychiatry. Our second study focused on the fetal anatomical survey. This US ultrasound scan allows us a more thorough examination of each organ of the fetus, including the different parts of the fetal brain, the fetal kidneys, fetal heart, the GI system, and many more organs, and is usually conducted between 19 weeks of gestation to 25 weeks. This study included 229 children with autism, matched once again to two control groups. They're typically developed siblings and typically developed children from the general population. Once again, examination of clinical and sociodemographic characteristics between the groups found no differences, except for gender-specific differences between cases and their siblings. Once again, a proportion of 1:4 in ASD children compared to 1:1 ratio between males to females in their siblings. When we examined the ratio of fetal anomalies in the three groups, you can see here black is children with autism, gray is their siblings, and white is the typically developed children. On the x-axis, you can see the proportion of children with one anomaly, structural anomaly, proportion of children with two anomalies, and the proportion with children with three anomalies. We saw that children with autism had 30% of children with autism had some kind of anomaly in their ultrasound scan, compared to only 15% in their typically developed sibling and about 10% in the typically developed population. A significant difference and a threefold higher rates of anomalies in their scans. Also, children with autism had significantly higher rates of multi-organ anomalies. Examination of specific organ systems showed that these children with autism had significantly higher rates of anomalies in the urinary system, mostly PL ectasis or dilation of the renal pelvis, a finding which is very common ultrasound finding, also considered a soft marker, which suggests some kind of genetic anomaly in a child. Another significantly higher finding was in their heart, mostly VSD, ventricular septal defects in these children, and echogenic intracardiac focus, which is also a soft marker suggesting some kind of genetic mutation in a child. The third finding was children with autism had significantly higher rates of anomalies in the head and brain, mostly in the CSF system, in the choroid plexus, lateral ventricles, and cisterna magna, which is in line with previous studies showing extraaxial CSF volume in children with autism. Other systems also showed high rates, even though they didn't reach significant significance. And the findings show that children with abnormalities had more severe autism compared to children with autism which didn't have ultrasonographic findings. In addition, we looked at once again at the children's head, and this study too showed that children with autism have smaller and dolichocephalic head shape, as can be seen here once again. But interestingly, when we looked at their eyes, we saw that they had wider set eyes. These findings are in line with previous studies showing specific genes associated with autism which affect the set of the eyes, wider set eyes, like CHD8, shown previously, or 16p11, as well as previous studies conducted on children with autism with not any genetic syndrome, also showing wider set eyes among these children. When we looked at differences between males and females with autism, we saw that ASD females had significantly higher rates of anomalies, of any kind of anomalies, as well as in their heart and head and brain, as well as higher rates of multi-organ anomalies compared to males. These differences were seen only in the ASD cases, and no differences were seen between females and males among their typically developed siblings and typically developed population. The study was published 3 weeks ago in Brain. And so both studies got lots of media attention in New York Post, Jerusalem Post, etc. And we hope they may maybe help elucidate the abnormality fetal growth of children with autism, and maybe help in assisting in early biomarkers for early diagnosis of children with autism. Our future directions. We hope to complete all other ultrasound scans conducted throughout pregnancy. Most of them are during the first trimester, including the nuchal translucency and the early anatomical scans. Also, we hope to conduct a phenotype to genotype study examining if children with specific anatomical anomalies in ultrasound have higher rates of known genetic ASD mutations, so that children with high risks, which have some kind of anomalies in their ultrasound, may be sent to genetic testing and find any specific mutations associated with autism, so we can have a higher suspect of autism risk in these children. And of course, a longitudinal growth study from prenatal life to early childhood to see if, in fact, their abnormal prenatal head growth is, in fact, doing this overgrowth later in life, as seen by previous studies. And that's it. Thank you very much. Yeah, that's our main concern when we found our findings. So I think one thing is actually saying that there is some kind of prenatal abnormal development. Like autism, until now we thought it starts later on in life. Something is going on during prenatal life. I think it's too early now to use this as a screening tool for parents to decide or to say this child have high risk of autism. It's still too early. But we hope that these early biomarkers may help to, and following our next study, which we're working on now, with preliminary results showing that these children with fetal anomalies actually have higher rates of specific genetic mutations associated with autism. So we hope that just as happening in other diseases, that a mother goes to the ultrasound scan, they find some kind of anomalies in the ultrasound, and they're sent to a genetic testing, and then they can say, okay, there's like 90%, 80% chance of having X disease. We hope maybe someday it could happen also in autism, and that way we can start early treatment of these high-risk children, which have been shown by a study also done by our center to ameliorate the autism severity. So we hope that's the future, we hope, but now it's only a preliminary study. We need more data on it.
This is exactly my question. Thank you for that very nice study.
Thank you.
But I was wondering, usually now when you see this type of malformations with a WIDAD or PSD, you advise for at least a microarray or genetic study. So do you have any results on those patients who had major malformations?
Yeah, so we have, I didn't bring it here, but we have preliminary results. We took these children with ultrasound, and we also have genetic data here in our center. And we have now it's about 200 children with both ultrasound and genetic data. And we saw the children with, we compared the children with fetal anomalies in ultrasound to children with no fetal anomalies. And we saw that children with fetal anomalies have higher rates of genetic mutations, SFARI 1 and 2.
They didn't have a prenatal microarray when
No, they didn't have prenatal microarray. They did genetic testing here in our center later on.
Just to remind that this is a retrospective study.
Yeah.
It goes from our sample from our cohort of the center back to the ultrasound.
Yeah, there's still more like prospective studies and larger study to see that our findings are actually true and correct.
Along similar lines, say for the people who are 10% or more, proportion of the heart rate, of the heart, sorry, was bigger, then what's predictive power of that in terms of autism? Have you looked at all in that in your data in those terms instead of just comparing between control and autism?
Yeah, you can definitely do that. Because it's a preliminary study, we just want to see if there's any association between it. I think future studies will need to see if it's actually a good screening tool, if we can actually use it, but we didn't do it yet.
Same question. We heard you talk about screening and the value of knowing the positive predictive value, because
Yeah.
this is what clinicians are interested in.
Yeah.
You get the test result, what is the chance that this patient really has autism or not?
Yeah. Yeah, so it's
You can calculate it from population data, I think. Using your data and having population data on genetic malformation or ultrasound malformations, I think it's maybe 3 to 4% normal people, right? And then you can calculate what your positive predictive value is.
yeah.
I can try to stratify your ASD cohorts to syndromic and non-syndromic ASD as you have the genetic results. Respective, but you have the genetic results. So I just want to know if the non-syndromic ASD also have differences, or it's just the syndromic ASD that pull the statistics.
Yeah, so we didn't do it in this study. Now we're working on the genetic data, and there's not so many children with syndromic ASD. Their group is very, very small. So I don't think they're affecting, like the numbers of children we see here with these UFAs is much higher than the syndromic children.
So you're saying even in non-syndromic ASD we'll find differences?
Yeah, definitely. We think that in syndromic children, like the studies, I'll show you here. Like previous studies done on like 2 to 3 children with syndromic ASD have also shown that all these children with the syndromes have like VSD or
This is for sure.
yeah,
This is not surprising.
yeah,
But
and
it's also going for the non-syndromic.
yeah. So we saw when we looked again. I don't have genetic data on all children with ultrasound, but among children with ultrasound and genetic data, most of them are children with no syndromic ASD. They may have some kind of mutation associated with ASD, but they're not syndromic ASD. And they still have higher rates of anomalies.
So to the same question, so I'm going to correlate also the mother's situation, I mean, the nutrition level, diseases like diabetes and high blood pressure. I mean, if it's not genetic, it's not a gene or several genes, maybe it's something to do with the environment. So this is something that would also be very interesting.
Yeah, so previous studies have shown that specific like infection, intrauterine infection, or higher TSH levels and other biomarkers happening during prenatal life affect autism, a higher risk of autism, as well as affect fetal development, affecting like specific infections affect the fetal heart, or affect the fetal kidneys, or affect the fetal brain. So maybe some of it is genetic, but others are environmental. But they both affect both autism risk. Yeah, yeah, definitely. Thank you.
One last question? None? Thanks a lot.
Thank you.